Dumelang sanbonani absheni. Hello, goeiemorgen. Welcome you all to today's mathematics lesson. My name is Mr. Makitla. I'm a lecturer at Nkangala TVET College, Middleburg campus. Today I'll be presenting to you linear programming from NCV Level 4. Okay? The textbook that I'll be using is the textbook I use to summarize all my notes and the one that I'll be referring to for today. It's published by Future Managers, Mathematics 4, Hands-on Training. Okay, I hope you have it. Okay, so linear programming. What exactly is linear programming? Why do we even need to know linear programming? In fact, what significance does linear programming play in our daily lives? Okay, and I believe, my opinion, is that in order for you to better understand the topic that you're doing and the work that you're doing, you need to understand its relevance and importance to everyday society. So linear programming is actually a system where we use functions, linear functions, or functions of the linear form, to best describe a particular situation. So everyday life, there's a lot of tasks and activities which are conducted. These tasks and activities can be analyzed and described in terms of a linear equation or a linear inequality based on what we're going to do now. How does linear programming fall into the picture? We would like to know how to maximize or minimize certain parameters based on our tasks. For instance, the local guy oyenza amakota at your local corner, at your street there, may want to know how to maximize their profit. Let's say the guy down your street is selling 3 different types of kotas, spatlos, some may call them. Spatlo number A sells for 26 rands. Let's write the information. So we've got product number A and product B on the board, and product C perhaps. Product A may cost 5 rands to make, and perhaps you are selling it, selling price at around 15 rands. Okay, in this case, we know that the profit will be 10 rands. I know this is not an accounting class, but just bear with me for the sake of the example I'm using now. Product number B could cost perhaps 7 rands. The selling price could be 16 rands, and perhaps your profit would be 9 rands. Let's limit it to 2 variables, because in our linear programming problem, we'll be dealing with 2 variables only, not more than 2. Okay, so if the guy selling the kotas at your local street may want to know, which of these kotas should I sell the most of? I have to sell both of them. I need to sell a minimum of the A kotas. I need to sell a certain number of the B kotas. In other words, you must sell both A and B. You can't sell B only. You can't sell A only. Now, the guy at the corner there selling, doing the sales, would like to maximize his profit. He would like to know, which of these should I make the most of on a daily basis? And which of these should I minimize on in order to maximize on my output and perhaps profit? Okay, so linear programming deals with these type of problems, where we can actually use product A and product B to model an equation. Okay, we'll model certain equations at a certain time, but nonetheless, we will use A and B to model our equations. Therefore, our linear program equations will only have 2 variables. I repeat, the problems that we'll be dealing with will only have 2 variables. These variables, in most cases, will be considered X and Y. I only used A and B to describe the situation at hand. Okay, so before we actually start solving the problems and dealing with the problems in detail, this was mainly the introduction. I'll delve deeper into it once we get further on. Okay. Now that we've established the importance of linear programming, where it may be utilized and how it may be utilized, it is important for us now to examine what information is required for you to know before you proceed. As I've already mentioned, this is level 4 linear programming. So I'm assuming that everyone who's taking note of this lesson is already aware of their level 2 work and their level 3 work. I won't delve too much into that, but I may touch on a few topics just to remind you. Okay, first things first. As I'm mentioning, this is knowledge that you need in hand before you can proceed further with linear programming. If you're dealing with linear programming, you definitely have to understand the difference between linear equations. Linear equations, some may consider them straight line graphs. Straight line graphs generally come in the form of y equals mx plus c, where m is the gradient of the equation and c would be our y intercept. Very, very crucial information. If you understand the general standard form of the straight line equation and you can manipulate an equation and put it in this form, then you've already done most of the solution. You've solved half the problem. Okay. Linear equations. Once more, straight line graphs. We should know how to draw the graphs as well. Ne? Must be able to draw the graph using whichever method you are comfortable with. Some prefer the table method. Some prefer the intercept method. Whichever one. You could either use the table method or the intercept method. Whichever method you prefer, it does not matter as long as your work is accurate and correct. Okay. Something else that we need to be aware of with regards to straight line graphs, linear equations, in some cases you will be given the actual graph and you have to be able to determine the equation of the graph or read off the values of the graph and derive or formulate the equation of that particular graph. It is important for you to be able to analyze the graph and get back to the equation. Once more, it's also important for you to, given the equation, to be able to draw the graph in question. Okay. Something else which we should be aware of. Allow me to erase this. Something else which should be in place and which you should be aware of would be linear inequalities. I'm sure you've noticed now that linear equations mean things are equal, whereas linear inequalities means the opposite. They are not necessarily equal. Okay. So linear inequalities we delved with or we touched in level 3. I will just remind you on certain issues regarding inequalities. Okay, first things first, we have our symbols. Let's call that Roman numeral 1, I. That's the first symbol to look at. Second symbol. Third symbol. And the fourth symbol. Let me just break them down for you on the side using simple and relevant examples. First one, if we've got a and the symbol, as you see on the board. How do we actually read this? We always read it from the left, as per usual when you read in your book or when you read any text. So how would we actually describe this inequality here? We would actually say that A is less than B. There's a small trick that I was taught when I was back in school in terms of how to analyze which one is less than or greater than. Consider this symbol, a mouth of a small little fish. My drawings and sketchings are not the best. I'm a mathematician, not a sketch artist. Nonetheless, I like to consider this small fish, A, B over there. A is the small fish trying to eat something from the big fish. Okay, so whichever side the mouth opens to, or whichever side the symbol is opening to, that is always the bigger side. Let's contrast this. As we said here, A is less than B. So in this case, we know that B is bigger. Bigger or greater than. That's the terms that they like to use, less than, greater than. It's fine, it's correct. Let's look at the second symbol. If we're using A and B again, A. In the second symbol, you will realize that the symbol is now opened towards A. Okay? It will read as follows. A is greater than B. Okay? Symbol number 3. We already dealt with the first symbol. We dealt with the second one. I'm just simply discussing the third one. Okay. What does the third symbol actually mean? I'm sure you'll notice that there's a line just underneath the symbol. This line should look similar. It looks like an equal sign, a 1/2 of an equal sign. That's because we are actually relating back to the equalities and inequalities in this case. Reading it from the left, we'd read it as follows. A is equal to or less than B. I repeat, A in this particular case would be equal to, based on this line underneath here, or less than B. Okay. The last symbol, read from the left as per usual, you would realize that in this case, A is equal or greater than B. Okay, just to recap on them. First scenario, A is less than B. Second scenario, A is greater than B. Third scenario, A is equal to or less than B. Last scenario, A is equal to or greater than B. Okay. We should all be satisfied with the symbols as they are. Let me quickly erase these. Some of you may already have questions. Do not panic. You can easily pose your questions on our social media pages as well as my own social media pages. The social media pages of the college as well as my personal own social pages. I'll give you the details at the end, but please do jot down your questions as we go along through the lesson. Okay, something else to be aware of. Didn't necessarily mention it here, but we should all know our basics. What are whole numbers? Integers. Whole numbers, integers. Real numbers. And under real we'll have rational and irrational. what you'll realize here is that I'm stating quite a lot of information which you've already come across in the past. Mathematics is a continuous process. We are building on the foundations that you may have learned in level 2, level 3, and your previous mathematical experiences. So you cannot disregard your previous knowledge. You cannot throw away your past textbooks. You cannot do any of that. You always need your information so you can quickly refer to what you may have done in the past. Okay, just to quickly summarize, whole numbers, as you and I may know, are numbers which do not have fractions. They do not have decimals per se. It's a whole solid number. We can consider it a number, basically it's not a fraction, it's a whole solid number. It does not have any decimals and none of that stuff. Here's an example of a whole number. 5 is a whole number. 72 is a whole number. Basically, any number that does not have a fraction may be considered a whole number. Okay. Next on the agenda, integers. Integers may be considered the whole number set from 0 going to the negative values as well as the positive values. Those are what we consider our integers. Once more, here's another example. In actual fact, in order for you to remember integers simply, generally draw yourself a number line indicating the negative values and the positive values, and you've summarized your integers. So I will sketch my number line as follows. It's a brief, short one. Got 0 over there, -1, and +1. That is an example of your integers. The number line continues further and further on. So any number on the number line can be considered an integer. Please do pay careful attention that you are not writing the values with fractions. Ideally, our number line, we use whole numbers. We do not want fractions on the number line, unless it's a specific special case. Okay? The last portion there, real numbers. You may also be aware of complex numbers or imaginary numbers. We are only dealing with real numbers. Real numbers are basically numbers which have solutions, and all of them exist within our systems. I just have to contrast with the fact that real numbers are basically the opposite of imaginary numbers. Imaginary numbers, when we can't solve certain problems or when we have negative square roots. Okay? Yeah, that summarizes the different number systems that will be required from us today. So this is generally some of the pre-knowledge which you should have in place before we proceed with today's lesson. I spent a bit of time on it, but I do believe the foundation is the key. Otherwise, you can never build a strong building on a weak foundation. It is at this point that I have to highlight how to actually draw inequalities, or how to sketch the graphs for inequalities. Sketching a graph for an inequality is very much similar to how you do it with an actual equation, but there's a slight difference, however. Let me just elaborate on that. We spoke about linear equations as y equals mx plus c. Okay? We obviously know it could be a positive gradient or a negative gradient. That's not what we're focused on for now. However, when we get to, this is an equation, when we get to inequalities, it's a whole different ball game. I'm using these two symbols just to denote that this is an inequality instead of an equation. It could be either one of the symbols, it doesn't matter. The fact is it is an inequality. Okay, so let me first start by breaking down this one. If we've got given the inequality on the board, we may read it as follows, that y is less than mx plus c. Okay? Do take note that this is a positive gradient, if you were to draw this particular type of graph, I know I've just done a big error or big mistake. We never draw Cartesian planes freehand. You must be using a ruler. But allow me, indulge me. I do know that wherever you are seated, you are definitely using your ruler, unlike me. Okay. Cartesian plane, given the following inequality, it's a positive gradient. So we are expecting a graph that's sloping from the bottom left towards the top right because of the fact that it's got a positive gradient. Okay. Now let's look over here. We said y is less than mx plus c in this particular case. What is y in this scenario? Y is the actual equation. Y is the actual straight line that you see on the board. That is the y value that you will see. Okay. Reads as follows: y less than mx plus c. After you've sketched the line, you need to actually shade the region that you are referring to. Symbol reads less than. Therefore, you will indicate the area underneath the line. I'll leave this on the board to contrast it with this one. If you have y, in this case I've sketched y is greater than mx plus c. The gradient is still positive once more. So if this were our Cartesian plane, this is our graph. This is y. The fact that we said y is greater than mx plus c means we'll be highlighting the region above the line. Okay. If the symbol is read y less than, then you indicate the region underneath your line. If it is y greater than, you indicate the region above the line. That is clear enough. I'm erasing this. I want us now to contrast two more different types of linear graphs of this nature. Once more, y positive mx plus c. To the untrained eye, these may look similar. But to you and I, you'll realize that in this case, y is less than mx plus c. Okay? Y is less than mx plus c. In the second scenario, however, y is equal to or less than mx plus c. Okay. Focus on the first one. In the first one, your graph, the actual line that you draw must be a dotted line. If it's simply y less than mx plus c, you will use a dotted line. Okay? We did say when it's less than, you focus on the region underneath. That's still the same. That has not changed. That part of the information remains the same. The second one here, having sketched our Cartesian plane, what you'll realize is that it's y is equal to or less than mx plus c. The moment you see this equal to or less than, then your graph will no longer be a dotted line. It will be a solid line. I repeat, if it's equal to or less than or equal to and greater than, you always sketch a solid line. If it's simply less than or greater than, then your line will be a dotted line. Okay? We did say that y is less than, so we are still indicating the region underneath the graph. I hope that covers the basics and the essentials that you may need before we proceed. I believe for today's lesson we've reached the end. However, I do believe you are in a better position to try out a few examples in case you are at home and you've got your textbook. We did cover all the essential basics and previous knowledge expected from you in order to proceed to linear programming in level 4. Okay. In the next lesson, I'll be dealing mainly with problems because we've covered all the theory that we had to today. Feel free, however, to contact me. I am available on Facebook. My Facebook name is Fatso Makitla. You can find me there. However, do contact us via the college's details. The college also has social media pages. We've got a WhatsApp page, Twitter page, and a Facebook page. So feel free to get hold of us, myself, or any of my colleagues via the social media pages of the college. Thank you.